Okay, so if you're like me, you've probably got a smartphone nearby, maybe even in your hands right now.
Almost certainly.
And it's kind of incredible, isn't it? When you stop and think about just how much power, how much tech is packed into this tiny little thing.
It really
You
is.
use it all the time.
Yeah.
But have you ever really, truly considered the journey it took? I mean, how did it even get here?
It's an astonishing feat, absolutely. And, what often gets missed is that it's not just about the amazing microtechnology itself.
Right.
It's about this incredibly complex global collaboration, a supply chain so intricate it's really a marvel of modern logistics and engineering.
Exactly. And that's really our mission today in this
Mm.
deep dive. We want to peel back those layers, uncover the story behind, all those tiny bits inside your phone.
Yeah, get into the nitty-gritty.
We're going to try and pull out the most important nuggets, give you a sort of shortcut to being really well informed about this thing we rely on like every single day.
Makes sense. Where should we start?
Well, let's kick things off by tackling something you see all the time. That little stamp on the back, maybe. Assembled in China.
Ah, yes.
That phrase.
What does that actually mean in the grand scheme of things? Let's unpack this a bit.
Okay, so it means exactly what it says. The final stage, the putting it all together, happens there. But, and this is the key part, the components themselves. They come from literally all over the world.
All over.
Oh, yeah. It's maybe the best example out there of a hyper-specialized, deeply interconnected global manufacturing system.
So we're not just talking like 2 or 3 countries providing parts.
Not even close. The origins are incredibly diverse. Think about the main processor, the application processor. That's basically the phone's brain, right?
Right, the core chip.
That's usually designed in the U.S. companies like, Apple or Qualcomm.
Okay, US design. What else?
Then you've got the memory, the RAM, the storage. That's very likely coming from South Korea. Giants like Samsung or SK Hynix dominate that space. South Korea for memory. Got it. What about the camera? Everyone cares about the camera.
Ah, the camera sensor, the eye of the phone. High probability that comes from Japan. Sony's a huge player there.
Japan for the
Oh,
camera sensor
okay.
and the screen. The display we stare at all day.
That beautiful display. Could be Samsung, again, they make amazing OLEDs, or maybe BOE, a big Chinese manufacturer.
Mm.
And the battery, the thing keeping it all going. Could be China, could be Japan, maybe Korea too. It varies.
Wow. So just for those few key parts, we've already hit the U.S., South Korea, Japan, China.
Exactly. It's quite remarkable. One single device, and you've got dozens of countries involved before those parts even get near a final assembly plant like Foxconn or Pegatron.
Dozens of countries.
Yeah, it highlights the surprising scale of international cooperation that's just, well, it's invisible to most people holding the phone.
Okay, so let's dive a bit deeper then. You mentioned the chipset, the brain. That sounds critical. Its journey must be pretty complex too.
Oh, absolutely. Here's where it gets really fascinating.
Lay it on us.
Right. So the chipset, it follows this very specific multi-stage path around the globe, as we said, often designed in the US.
Okay.
Then it gets actually manufactured usually by a company called TSMC in Taiwan. They use these incredibly advanced, unbelievably precise processes.
Taiwan for manufacturing the raw chip. Then what?
From Taiwan, it typically travels again. It needs to be tested rigorously and then packaged. That often happens in places like Malaysia or the Philippines.
Testing and packaging in Southeast Asia.
Exactly. And then finally, it gets mounted onto the PCD. That's the printed circuit board, the green board, everything connects to. And that step usually happens in China, often near the final assembly location.
Wow. U.S. design, Taiwan fabrication, Malaysia or Philippines for testing, China for mounting. That's quite a trip.
It is. And this isn't quick. Just that journey for the chipset alone, it can take months. And it demands just insane levels of precision at every single step.
Months for just one component's journey.
Yeah. And what's really insightful here is seeing the specialization. You've got these key global players who do just one specific critical thing.
Like who?
Well, you have ASML, they're Dutch. They make the lithography machines, the super complex, super expensive machines that actually print the tiny circuits onto the silicon wafers. Absolutely essential.
Okay. Netherlands providing the core machinery.
Then you've got companies like Applied Materials from the U.S. providing other types of manufacturing equipment. And then firms like ASE, based in Taiwan, specializing in that final testing and packaging phase.
So it's like a chain of specialists.
A chain of miracles, almost. Just to get that one brain chip ready to go into your phone, it shows this hyper-efficient global system, but you can also see how fragile it might be, one break in that chain.
Right, we'll get to that fragility. But first, even before these high-tech parts, there's something more basic, right? The actual raw materials.
Ah, yes, the very foundation.
I mean, have you, our listener, ever really heard of things like tantalum or cobalt, neodymium?
Probably not everyday conversation, but these and other rare earths and critical elements play an absolutely vital role inside your smartphone. You can't make one without them.
Okay, tell us more. Tantalum, what's that for?
Tantalum is crucial for making tiny, high-performance capacitors. These little components basically manage power flow within the circuits. Very important.
Right. And cobalt, I think I've heard about that one in relation to batteries.
You got it. Cobalt is a key ingredient in the lithium-ion batteries that power pretty much all smartphones today. Affects energy density, lifespan.
Okay. And neodymium. Sounds exotic.
It does. Neodymium is a rare earth element used to make tiny, powerful magnets. Those magnets are what make your phone's vibration motor work, the little buzz you feel.
Huh. Never thought about that. So where do these essential kind of hidden ingredients come from?
Well, their journey is just as global and sometimes more fraught. They're mined in various parts of the world. Tantalum often comes from the Democratic Republic of Congo, for instance.
DRC.
Cobalt also heavily sourced from the DRC, which raises significant ethical concerns we should acknowledge. Australia is another major source for some of these. And China is dominant in mining and especially processing many rare earth elements like neodymium.
So mined in places like DRC, Australia, China. Then
Well,
what?
Then they have to be refined, processed, which is a complex industrial process itself, and then distributed globally to the companies that make the components, like the capacitor makers or battery manufacturers.
It's just layer upon layer of global movement.
Exactly. And it underscores a really critical point. Without these fundamental raw materials, often sourced from just a few key places, none of the advanced stuff we talked about, the chips, the batteries, could even exist.
No rare materials, no smartphones. Simple as that.
Pretty much. It highlights this deep, often invisible layer of global dependency and also potential supply risks and ethical challenges tied to sourcing.
Okay, so we've got materials mined globally, processed, turned into highly complex components made in different specialized countries,
Yeah.
shipped around the world. Now, how does it all finally come together? What does this final assembly phase look like?
Right, the final puzzle piece. This is where those assembled in China labels come in. All these millions and millions of individual components, the chips, the screens, the batteries, the casings, screws, everything, are shipped to these enormous factories.
Run by companies like Foxconn.
Exactly. Foxconn, Pegatron, Wistron. These are the giants of electronics assembly, mostly operating vast facilities, primarily in China historically, though that's diversifying a bit now.
And the scale must be immense.
Oh, it's hard to comprehend. You're talking about factory complexes that are like small cities, tens of thousands of workers on assembly lines, operating with incredible speed and precision, putting together millions of phones every single month.
Wow. Millions a month.
It's a symphony of logistics, just getting the right part to the right station at the right second.
Okay, so the phone's built, it's tested, boxed up, but it's still probably in China. What happens next?
Then it embarks on its very last journey, global logistics, getting the finished product to you.
Right.
These assembled phones are loaded onto pallets into cargo containers and then transported using this massive, intricate network of air cargo, sea freight, sometimes trucks and trains.
All heading out across the globe.
All heading out to distribution centers, then to retailers, and finally to customers in, over 190 countries around the world. It's an unbelievable dance of supply, demand forecasting, and just-in-time delivery.
It sounds incredibly efficient, but also maybe incredibly fragile.
That's the word. What's truly striking, and yeah, maybe a bit unsettling, is just how vulnerable this whole complex, interconnected system actually is.
How so?
Think about it. A single missing component, maybe a tiny capacitor held up somewhere, or a delay in one specific factory or shipping route. That tiny disruption can cascade through the whole chain.
And delay millions of phones.
Absolutely. It can halt production lines downstream and delay the delivery of millions of finished devices reaching consumers.
Which brings us to a really important point, I think. What happens when this chain actually breaks? We've seen glimpses of this recently, haven't we?
We certainly have. And it's a real-time stress test of this whole global interdependence model. It shows how that just-in-time efficiency everyone aimed for
Yeah.
can very quickly turn into a just in case it breaks kind of nightmare. It's forcing a lot of companies to rethink things, maybe prioritize resilience a bit more over just pure rock bottom cost optimization.
And the examples are pretty stark. I mean, the COVID-19 pandemic obviously threw a massive wrench in the works.
Huge disruptions, factory shutdowns, shipping bottlenecks, worker shortages. It hit every part of the chain we've talked about.
And the chip shortages, too, that's still echoing.
Absolutely. That's
Yeah.
a perfect example. But it doesn't even need a global pandemic. Think about more localized events.
Like what?
Okay, say there's a severe lockdown in a specific city in Malaysia for health reasons. That could shut down a critical chip testing facility for weeks.
And that halts chips needed by everyone.
Exactly. Or an earthquake hits Japan. That could potentially damage a key factory, making camera sensors, creating a shortage felt worldwide.
Right, natural disaster.
Or even political tensions. Think about the key regions involved: Taiwan, China, the U.S., South Korea. Any significant political instability or trade disputes between these major players can send shockwaves rippling across the entire market.
Suddenly impacting the price or availability of the phone in your pocket.
Precisely. It really hammers home the point. Your smartphone isn't just, a cool piece of technology. It's a physical object that embodies how deeply interconnected and maybe interdependent our world truly is.
It's quite sobering when you lay it all out like that. So maybe the next time you pick up your phone, pause for just a second.
Yeah.
That incredible device, it's not just a gadget you bought off a shelf.
Yeah.
It's really the culmination of this massive, mostly unseen global journey.
It truly is. The result of, thousands upon thousands of engineers, factory workers, miners, designers, logistics coordinators, countless suppliers and global partnerships, all somehow working in this incredibly delicate harmony most of the time.
It's a testament to human ingenuity, really,
Yeah,
and global cooperation, even with all the friction points.
absolutely. And we hope this deep dive maybe encourages you, the listener, just to think for a moment about that vast, intricate web, the people, the places, the processes that brought that device into your hand the next time you use it.
Definitely gives you a new perspective and maybe leaves us with a final thought to chew on.
Go for it.
Given just how deeply global, how complex, and how interdependent this smartphone supply chain is, what does that tell us about all the hidden connections and maybe the hidden vulnerabilities in other seemingly simple objects we rely on every single day?
That is something to think about. What else looks simple but has a story just as complex?
Exactly. Food for thought?